Now, as of now, you know the what is variable, right? Variable and the value and ID function as of now. Okay. Now, why this pointing out to same memory location? I will explain you. But here you should understand one thing is this is shift is there, right? Shift is a value which is assigned to a variable, or variable is pointing to the, you know, a look where the shift is there. That is what it is being showing to us. Okay. 1 second, guys. Okay, now let me show you that this is what we are talking now. This is the basic fundamental thing is the value plays an important role. Once we use the value, that will occupy the memory, and that value, when a memory is occupied, it will have the address. Okay, now let's go to the next important point. So we didn't talk about dynamically typed yet. Okay, now we are going to talk about dynamically typed. Before talking about dynamically typed, let's talk about the Python data. Python data. What are data types? Means types of data. Now here you can see this. How many types of data types are there? One is string type, one is integer type, other one is float, right? These are like types of data. The types of data is like is called as data. In the programming terminology, we call it as data. Now, Python has two types of data types. Oddly, very broadly classified, they are having two types. One is called as fundamental data type. One is called as sequential data type. Okay. Now, this fundamental data type, under the fundamental data type, we have the integer. Next one is a float. Okay. Next one is a complex. Next one is the boolean. Bool. We call it as bool. This is actually bool. Okay. And then there is a string. Okay. And when it comes to the sequential data type, we have list, we have tuple, we have set. This is called as sequential data. All these things are called as sequential. Okay. Now, what is the first is, you may ask me a question. What is data type? Is nothing but types of data. We have seen very detailedly about data. Data can be of different types and all those things. Now here in the programming terminology, we will have broadly classifying, we will have two types of data. One is a string type, second one is a numerical type. Okay, whatever you take it, the data, what we are going to use it in the program is string type and the, you know, integer type or a numerical. Okay. Now, what is the difference between a fundamental data type and a sequential data? Now, fundamental data type, first property is, okay, property of the fundamental data type is, first property is, the fundamental data type is immutable. Immutable. First property is fundamental data type is immutable. Next one is, okay, the variables, okay, the variables holding the same value point out to the same memory location. Variables holding same value refers same memory location. Okay. These are the two important properties of the fundamental data. Okay, first one is I will just take this one. Okay, what is the fundamental data type is? Fundamental data type is, first is immutable. Immutable means you can't change it. Okay, you can't change it. Second one is variables holding the same value will be pointing out to the same memory location. Okay, 1 second. Sorry for that. Okay, so fundamental data type is immutable. That is, you can't change it. And variables holding the same value refers to the same memory location. So I will explain you what is this. Okay, first thing, coming down to the sequential data type. Sequential data type is first property of the sequential data type is it can a variable under a variable. Here, if you see that, here I gave it. A variable is pointing out to the only one value, right? It is holding a one value only. So here, what is a sequential data type is sequential data type can hold the multiple values. Okay, sequential data type can hold multiple values. Multiple values means multiple, you can have the multiple values under one sequential data. For example, here I will give it here. Here A is equals to, I gave it as 2 1 2 1. So here you are holding only one value. What is this? Integer. Integer is called as a, normally we call it as a fundamental data. Now, if I say it as sequential data, I'm taking as x is equals to, here I'm using 100, 200, 300, 400, 500. How many values are under x? Now 5 values are there under x. Now how many values are under a? Only one value is there under a. Okay. Now this is the difference between a sequential data type and fundamental data type. Only one difference I'm talking about. First one is fundamental data type is like this. This is the one. Okay, this is a fundamental data. When it comes to a sequential, under a variable, you will have the multiple values will be there in this. Now, these multiple values, I gave it 100, 200, 300, 400, 500, right? Now, this can be of different types also. What I mean by different types means you can have a integer, you can have a float, you can have a string, anything. These values, not only this way, all of them should, it's not a rule that all of them should be integers or all of them should be a float, all of them should be a string. No, it is nothing like that. You can have the mixed variables also. So when you have all of them of same variables, we call it as homogeneous. Homogeneous. And when it comes to the mixed variables, we call it as a heterogeneous. Okay, we call it as heterogeneous. So here, what is this? The sequential data types can hold multiple heterogeneous values. Heterogeneous values. So hope you got it. So it can hold the multiple values, and what type it is? Heterogeneous, not the homogeneous. You can give the homogeneous also. You can give all of them of one type. It will accept. But the what is the flexibility? It can accept the heterogeneous values also. Okay. Next one. Okay. Now you may ask me a question. Like, see Arjun, if this is there, if I want to use this, what you are going to do? A, print A. What you are going to get it? 21, 21. Now, if I want to print Y over here, just take it Y. Now, what I'm going to get? I will get it all these. Now, can I get the individual values? Yes. Individual. Why? How you can get these individual values? Because each and every value inside this will be stored in a separate memory location. Again, remember that each and every value will be stored in a separate memory location. So when they are having a separate memory location, so you can extract. So here, first point is multiple sequential data types can hold the multiple heterogeneous values, and each of the value is stored in a separate internal memory location, in a separate internal memory location. Or these multiple values stored in separate internal memory location. Okay. In a separate or series of internal, anything you can use it. I can use a series of internal memory location, or each of them is having a separate memory location. You can say, okay. First thing, this is next one is these internal memory locations where these individual values are stored are identified with a concept called as indexing. These internal memory locations are identified by indexing concept. What is this indexing concept? Is again, if you don't get it, it's okay, guys. We can discuss this one very detailedly, but simply I'm sharing it. If these are there, this one is there. I'm putting one over here. Okay. Now, what is that we said it? This is a sequential data type. Now, sequential data type can hold the multiple values over here, right? Now, these multiple values will, what happens is they are stored in a separate individual memory location over here like this. This will be stored in a separate memory location like this. 100 will be stored and 23 will be stored in a separate internal memory location. These internal memory location is identified a concept called as indexing. What is that is? This one we will give it as 1, 0. This one we will give it as 1. This one we will give it as 2. Now the name of this one we gave it as Y. So if I want this one, I will give it as Y of 1. Again, this is a very big concept. It is not like a small concept. So it is a very big concept of the indexing. So I'm just giving a very broad view. Okay. Now, if I'm printing only Y, then what I will get it? I will get all these three values. All these three values I'm getting. If I'm saying Y of 1, Y of square brackets of 1, then this will get it. This one will get it. This is the concept of indexing. Okay. Now, why I'm saying this concept of indexing now means because I'm using the term over here. I'm using the term, and you should not be feeling that, okay, what is this indexing? And you should not be in the back of your mind that what is this? So this is nothing but identifying the internal memory location uniquely. We are going to use it, the indexing concept. Okay. Now this one is, we are going to see this one later, especially the sequential data type. We are going to see that one later. It's a very big concept. And in this, these two are really very, very important. This one and this one. Now, whichever one I showed you just now, here like this, I showed you something. This one is nothing but a list. Okay, the example is list. These all are little bit changes, but mostly like 60–70% of the time they will have the same properties. Okay, these two are very, very important. List and the dictionary are really very important. Now, coming down to our fundamental data type. Now, let's talk about our fundamental data type. Okay. Now, fundamental data type first property is what? Immutable. What do you mean by immutable? Means you can't change it. I gave it. But it is a very vague idea. Now, I will tell you what is this is. We are using a value. Now, my value is, I will give it as I will say that rock is my value. Okay. Now we know that as soon as I use a value in the editor, this will occupy memory. right? Rock will occupy the memory over here. I'm putting it as R-O-C-K, rock. This will occupy the memory, right? This will definitely occupy the memory, guys. No doubt it will occupy the memory. Once it occupies the memory, it will have the address. We know that it will have the address. I'm giving some address over here, something like this. Like this is the big address we are having. Okay. This is the Now, in the same, once a value occupies the memory, remember this is a very important point. Once a value occupies the memory, okay, once the value occupies the memory, that value inside the same memory location, you can't change it. Inside the same memory location, you can't change that value. That is what I mean by immutable. So inside the same memory location, you can't change the value. It is like an you can't change it. Here, this rock inside this address, same memory location, you can't change. This is what you mean by immutable. Now, like this, if you want to change it, like here, I want to remove this value completely. And I want to put it as maybe here, like maybe stone. Inside the same memory location, I can't do it. No way. We can't do it at all. So inside the same memory location, once the rock is used over here, so rock will be there with us forever. This is forever. Okay. Once a value is occupying the memory, remember this. Once a value is occupying the memory, inside the same memory, you are inside the same memory, you can't change the value. That's it. Okay, that's it. You can't change it. This is what I mean by memory. Now you may get a doubt. So once it is created, so we can't change it. That means that will be forever. Yeah, that will be forever. Means that memory will be blocked. It's not that it is blocked forever. See, and first a variable will be assigned over here. Like a variable will be assigned to this row. That means whenever I want to use the rock, I will call it with the print A, right? I will use the print A and I will get the rock. We know that whenever I want rock, I will use A and I will get the rock over here. That I know it, right? This is the one. Okay. Now, if suppose this variable is not there to the rock, if this variable is not there to the rock, then this one I can't call it. It is waste. I can't call it. So there is something called as garbage collector will come and delete this. Now you may ask me a question. Just now you said that it is not changeable. How it can be deleted? It can be destroyed or deleted, but you can't change the value inside the same memory location. It can be deleted completely. It can be, the memory can be freed with this value. That can be done by the garbage collector. But the value inside the same memory location, I can't change it. That is the meaning of the immutable. Immutable means the value once occupying a memory location, that value inside the same memory, we can't change. That is what I mean by immutable. Remember that. Okay. That is what it is called as immutable. Now, what is the next concept over here? The next concept is variables holding the same value refers to the same memory location. Now, variables holding the same value refers to the same memory. What I mean is, see, if we are having something called as now, if I'm having a word called as wind, I'm writing it as wind. Now, this wind we are using in our program, right? We are using in our program. Now, okay, let me write it down over here. Then it will be much better. I'll write a small code over here. A, or S is equals to, I will give it as win. And now once, and if I use it again, like R is equals to wind again. Okay, this is wind and this is also wind. The both the variables are holding the same value. Okay, now what is this happening is, this is the wind is there. Now we know that we are talking about this one. Wind is occupying the memory over here. Wind is occupying the memory. To this memory, we will have the address, right? Some address I'm giving it over here. This is the address. This one I'm talking. S is pointing out to this memory. Okay, this memory. Now, if I print ID of S, then what I'm going to get it? I will get it this one. Because wind is the value which is occupying a memory. To that memory, we are having an address. Okay, and S is pointing out to that. Now let's take this one. Okay, let's take this one. Air. I will take it as air. Air is the word. Now in this case, what happens? Actually, air is an okay. Now R is pointing out to air. R is pointing out to air. And here we will have a separate memory, separate address will be there over here. 120 something. This is having separate memory address. This is having separate memory address because this is a separate value which is occupying the wind is occupying the memory, and that address is this, and air is this. Okay, this is what it is happening. Now, next one. If we are having air over here in the place of air, or let's take it one more over here. I will take it as M. M is equals to wind. Now, actually, what we think it like, as the wind is occupied a separate memory location, air occupied the separate memory location, the wind will also occupy a separate memory location over here like this. And maybe it is having a altogether different address like this, where M is point. This is what happens with the other programming language. Other programming language, this is what happens. Wind is stored in a separate memory location where S is pointing. Air is stored in a separate memory location where R is pointing. And again, wind is stored in a separate memory location where M. This happens with the other program. But what is the advantage of the Python? See, this is the variable S. This is the variable M. What is their values? Their values are same. Their values are same. So what the Python will do is like, they will point the value, the variables which is having the same values point out to the same memory location. The S will be pointing to the same memory location. M will also point out to the same memory. This is what exactly happens. Now it will not allocate a separate memory like this. This is a very, very important concept over here. Okay, so the variables pointing out to the same memory location will be referred. Variables holding the same value will point out to the same memory location. Now, if you take it, if wind is this air is there, air I remove it and I will put it wind over here. Now this R will also point out to the same memory. R will also point out to the same memory. Okay, now R will, if there are like one more, now this is not be there because we don't have the air. Now if I take it like maybe N is there over here, like N is also having the wind. Now n will be pointing out to the same memory location. Now, if there is again k is also there with a win, k will also point out to same memory location. A is also having win, a will be pointing. B is also having win, B will be pointing. Like this, all of them will be pointing. The variable which is having the same value will be pointing out to the same memory. Okay, these two are very important properties. Okay, now I have to prove this one. Okay, if I have to prove this one programmatically. Okay, first is like, what is my first thing is, it is immutable. Immutable means, see, first thing is what I mean by immutable, that is the value which is occupying the memory. Okay, once it is occupying memory, that value cannot be changed in the same memory location. No, it is not going to be changed. Okay, so now you see this, I'm going to show you the immutable property over here. Now try to understand this, guys, because I can't show you as I showed you diagrammatically, I can't show you over here, but I will show you with the address. Now here I'm having a is equals to something like wind. A is equals to wind, and I will print a. Okay, and I will print ID of type of A, just to make sure that this is string type. Now print ID of A. Now I just explained you why we have to combine these two, right? Because type role is to get the data type, print role is to display it on the screen. If you want to get it onto the screen, you have to do this. And ID role is to get the address. The print role is to print it. So I'm putting the ID over here. Now this will definitely get the address. No doubt it will get the address. Okay, now I will run it. See this. Okay. Now see this one, guys. Now wind is a value which is occupying this memory. Okay. Now I will run it again. Okay, I will run it again. See the value, try to remember the value, at least last 5 digits, 37584. Now I will run it. Now this is changed. Now why that is changed? See, the basic understanding is this is occupying the memory, and that memory is occupied until and unless the program is running. The life of this value occupying this memory is until and unless your program is running, that is program is executed. Once the program execution is done, that memory will be released. Okay, that memory will be released. That is that value is gone, that memory is gone. So again, if I'm running it again, means again, if there is a new space is there, wherever the new space is there, it will allocate, and that is shown. So every time the life of this variable occupying this memory will be as long as the execution goes. Now you may get this execution is only for few seconds. Yeah, that is a lie. Now in the future, because every time we will be losing the values, so we will store it in the external memory. That is in the files, in the databases, something. There actually the databases for the external memory comes into picture. So this one is, now I'm running it over here. You see this? It will take it each and every time a different memory location will be there. Okay, clear? Hope you got it. Now this wind is occupying the memory, that's for sure. Now what I will do it is, I will try to change the value of A. I will use the separator. I will try to change the value of A over here. Okay, that is A is equals to, or we can take it as A is equals to. This will raise a lot of questions in you. Just wait. A is equals to, I will keep it as maybe windmill. I will give it as windmill, or let me take it as solar. Now here, this is a wind and this is a solar, two different values. Now I'm going to print it over here. This is the same A, right? I'm going to print it over. Clear? Now you can see this. Wind is occupying a different memory location, and this is occupying a different memory location. Now, what I'm trying to say is, first thing, the doubt what you get it is, we are talking about immutable. So how the value got changed? How the value got changed? So I will explain you. Here the value is not getting changed. Okay, you should know that here the value is not getting changed. So what is happening is, there is wind is there over here, wind. This is occupying a memory, and A is pointing out to this, and this address is this. Okay, this. Now, when I'm saying solar, solar is occupying the separate memory. Solar is occupying the separate memory. Only thing is that the reference of A is getting changed. Previously, A reference was this one. Now the A reference is this. That's it. A reference is this. Now this reference is gone. This reference is gone. So we don't have that. There is no reference is there over here. There is no variable is pointing to this one. So garbage collector will come down and delete it. Within more time, it will delete it. That is an internal mechanism. Our involvement is zero. Okay. Now the A is pointing out to where this one. So what it is showing is, if a variable, if the value is occupying a memory with this address, inside that I can't change it. That is what it is showing is. This address is different. This address is different. So inside, once a value occupies a memory, that memory address can be destroyed, but you can't change the value inside the same memory location. That is the reason why. If the immutable is, it is mutable. If the immutable is not there, just take it as immutable is not there. Solar is not there. So what will happen is, if immutable concept is not there, we can change the value inside this, and we can give it the solar over. And previously wind was there, wind address is this. Now solar address should be also this only. If it is mutable, that is inside this, if we are changeable. But that is not possible. This changing is not possible. So wind is there in this, it is having this address. Now solar is occupying altogether a different address over here. Why? Because the value inside this address is non-changeable. It is immutable. So what is this happening? It looks like changing is there. It is nothing but the reference of this one is changed. So this reference is gone, and latestly this one will be displayed. Now you may say that, no, then there is no way of getting, no way of getting the wind. Again, if you want the wind, you have to assign a new value to the wind over here. Over here, now wind will be pointing out to this position, and this will be wind. Okay, like again, I have to say A is equals to wind. This we can't get it. This is gone. That is gone. Okay, that is what it will happen. So this is the reason why it is called as immutable. So inside the same memory location, we can't change the value. Okay, but this changing of the value, non-immutable, is possible with the other programming language. Now, is this an advantage or a disadvantage? Means it is the biggest advantage of the Python, because it has an amazing memory management structure. Now, I will tell you why it is biggest advantage of this is this. Now, second point is the variables holding same value will point out to the same memory location. What is this concept? I will call it as memory sharing. Okay, let's take it as memory sharing. Fundamental data type. Fundamental data type. I will say that memory sharing. Okay, let me do this one.